Hello guys, today we have lead code question number 3004, maximum subtree of the same color. So in this question we have been given an n-ary tree which has n nodes, and also we have been given n minus 1 edges, and this tree is rooted at node 0. Now we have been given these edges, also each node has some specific color, also we have been given a list of the colors for each node. Now we have to find the maximum size of a subtree which has all the nodes of the same color. For example, here in the example one we have tree rooted at node 1, and the size will be 1. Also the all the nodes there are just the same color, which is color red. Okay, so the answer here will be 1. In example number 2 we have the subtree rooted at 2 as the answer, and the size of it is 3. Why? Because all the colors in the subtrees are same, so the answer will be 3 here. Similarly, example number 3 also we have the answer as 3. Okay, so how can we approach this question? Okay, so first observation that I can make here is that if any of the node has different colors, all the ancestors of that node will not be eligible to be counted for the answer, right? Because at least because two nodes have proven to be different colors, so all the ancestors will have different color nodes as their subtree, in their subtree. So that's one observation. Now how to ensure that all the nodes in your subtree has the same color? So for this we can use post order traversal, where from each subtree we will get the information whether that subtree has all the same colors or not. Okay, if so we will fetch that color plus the size. Okay, from each subtree we will do this. Okay, let's say I'll just give an example here. Okay, okay, let's say I have this node which has color 2, and node which has color 1. This node has color 1, this node has color 1. Okay, also we have this node 6. Okay, this has color 6. Here we also have color 6, and the color here is let's say 2. Okay, now I am standing at 2. I will first check for this subtree. Okay, it has all the nodes as 1, so it will return 1, and it will return two things. One, and it will return two things: the color and the size of that subtree. Okay, if that subtree has all the colors same, it will return that respective color, else it will return -1. Let's think of it this way: if all the nodes have the same color, we will return that color, or else if any of the nodes have different color, we will return -1, which indicates that this current subtree is invalid, implying the current node cannot be a valid subtree. Here a valid means all the colors of the subtree are same. Okay, so that's one thing that we are going to do. Okay, so for this 2, left subtree will return 1, and the right subtree will return -1, because we have colors 6 and 2, so it will return -1. Now for this 2 we have received at least one -1, so this 2 itself will not be valid for our answer. But if we had 6 here also, then this subtree would return 6, and this subtree would return 1. Now these two subtrees don't have the same color, which means again this node 2 will be invalid for our answer. Okay, great. But if this also had 1 1 1, even now my current node will be invalid, because all these subtrees have the same color among themselves, but it's not the same with 2, so again this 2 is invalid. But if this 2 had the color as 1, then this would be a valid subtree, and this would be considered in our answer. We will calculate the size using this respective sizes of all the subtrees, we will add them up, also add +1 for the current node. That will be the candidate for our answer. Okay, so this is how we are gonna go. If we find any of the subtrees with -1 as the color which it has returned, the current subtree will be invalid, and it will it will return false values. Okay, I think we can move ahead with the implementation. We will of course use recursion here. So let's go. First we have to build the graph. So n will be the size of the graph. So edges dot size. Great. Now let's make the tree. Yep, we have now made the tree. Okay, so I'll just this lambda function will be returning the pair of integer comma integer, and the name will be solve. Okay, and the arguments will be the current node and the parent. So accessing all the outer elements by reference, and okay, now we have done. Okay, now let's move around. Okay, this will contain all the colors, and if the size of this set goes more than 1, our current node will become invalid. So I'll just write it here. Also this child cannot be parent. Color will be solve. If this color itself is -1, then we can simply return -1. Okay, if this color is -1 or this size is -1, I can just simply return -1. Okay, great. Okay, now if this is not the case, if both things are okay and the color is there, which means that this subtree has all the colors same, but that color itself can be a different color than the current node. Okay, so I'll just check if this C is not equal to colors of node, if this color itself is not the same as the color node. Okay, I will again return -1. Great. And I can just keep doing that. Also I can just keep track of the size. Okay, integer size total, initializing it with 1 represents the current node. And if these things are not there, size total plus equal to size, and I'll just return size total. I'll return size total and the current color, the colors node. Yep, I think this is pretty much it. Also this size, if it's valid, we'll also have to consider it for our answer. So okay, answer can be at least 1 because every single node has 1 color, and that single node can be considered as a subtree. That node being a leaf node, it can be considered as a subtree. So yeah, answer equal to max answer and size total. Now that the current node is valid, we can consider this for our answer. Okay, and I just return and just return the answer. Yep, we are, I think, okay. Now I can just dry run this over this example. Okay, over example 2. First, let's make the tree really quickly. Okay, so initially we have the color 0, and okay, this colors this is, let's say the color is 1 here. The color is, okay, so it is red, so I'll just name it as red. We have green here, we have blue here. Okay, we have blue here and we have blue here. Okay, this is my tree. Okay, fine. Okay, now I will just perform this post order traversal. Okay, so initially I am at B. There are no children. Okay, so the size will be 1 and the color will be 1, so it will return 1 comma B. Similarly, this will return 1 comma B. Now I am at B. I will check for here and here. Okay, so I am getting 1. The color is same, cool. The color is same, cool. Okay, so this tree becomes valid, will be considered for my answer. It will return B 3 comma B. Similarly, this will return G comma 1. Okay, so 3 has been considered as our answer. Now I am at red. I will check for the left subtree. Any subtree you can check first. Now this color does not match, so I will just simply return -1, and this red will not be considered for our candidature. So my answer becomes 3 here. Okay, let's just check this code once and just look for any potential bugs. Looks okay. And pairing and the size total. Now checking for the color for children. Cool, let's name it as color child is -1, or the size itself is -1, so I'll just return -1. Great, which is correct. And if both of these cases are not met, which means that subtree is valid and has the same color. So I'll just increment my size total with the size of the subtree. Answer will be this maximum, and just returning the size and the color of the current node. Now size total and the current total looks good to me. We can just run it now. Should be okay. Okay, so it's failing here. I don't know why. Maybe let's just try to draw it now. Okay. Okay, so we have okay, so we have 0 connected to 1. Okay, color. Okay, so 0 connected to 1, 0 connected to 2, 2 is connected to 3, 2 is connected to 3, 2 is connected to 4. Okay, fine. Now 0 has color 1, 0 has color 1, 1 has color 2, 2 has color 3, 2 has color 3, 3 has color 3, 4 has color 3. Now the answer has to be 3, but it's not coming out to be 3. Let's check why. There must be some problem. Okay, this tree will return if there are no children at all. Okay, so the answer will be maximum size and okay, looks okay. Okay, so this is giving 4, this is not giving. Okay, let's see why. Answer 1. If color child is -1 or size is -1, which is technically correct. Hmm. If the color for that child, if child is not parent, which is also correct. Hmm. Color child is -1 or size, okay. Okay, let's say I am standing at here. Okay, let's say I am standing here. Now colors of node, color child, here will the color child will come. Looks okay. Solve child node. Solve. Okay, let's try to dry run really raw way. Okay. Oh. Okay, so it just checks here and then returns -1. Okay, but it has to check for all the children. Fine, fine, fine. Okay, so it has to check for all the children, but it is not doing that currently. Fine. So how can we resolve it? Okay, I'll just continue then. Okay, bool is okay is equal to, let's put a flag. Okay, is okay equal to 0. Similarly it will be done like this, is okay equal to 0. Also we don't need this, right? We don't need this, this is sufficient. Now if not okay, if not okay, I'll return fine. Yep, it should work now. Yes, it has worked. Now let's submit the code. Yep, it has gotten submitted. Now let's think why it was breaking. Okay, so my test case is this. Okay, 1 2 3 and 3 3. Okay, these are the colors of the nodes. Okay, now what it was doing is, I am standing at 1. I will check for one of the subtrees. Now the color hasn't matched. Okay, which means that it will just return -1 and -1. So this was not getting checked all along, right? So I just prevented that by tweaking my code. So yeah, now speaking of time complexity, the time complexity here will be big O of n into big O of n plus e. This will be the time complexity. So yeah, so also the call stack will be the maximum depth of the tree, which is on average big O of log n. So I hope you like the approach. Also hit like and comment if you want. So yeah, thank you and have a nice day. Bye.